Hello everyone, today's problem is submitted by a viewer and it says the parabolas with equations y equals k minus x plus 2 squared and x equals k minus y plus 2 squared touch, i.e. meet tangentially at a single point. It follows that k is equal to 1, 9 over 4, negative 9 over 4, negative 1, or root 2. Okay, so first let's try and understand a little bit about what's going on here. So the parabola, we'll start with the parabola y is equal to k minus x plus 2 squared. So if we go to x equals negative 2, and then we go up to some value, we'll call this k. When x is equal to negative 2, we're here, and then it's a parabola opening downward, like that. And the other parabola should just be reflected in the plane like this. So the way I'm drawing this is kind of only appropriate for positive values of k. Right? So we can see, for this, almost certainly these will never, if I extended these out like that and altered the value of k, almost certainly they will never touch tangentially. So we're probably going to need k to be negative. So let's redraw the picture for what a negative value of k might look like. In fact, I'll only need the negative axes for x and y. So this corresponds to a value of k about negative 1.5. So we should do the same thing here. Okay. So as I make k more and more negative, this point will start to move down, and this point will start to move left. We see that we might eventually get some tangency between these two things. I'm looking for a picture that looks something like this. Okay, this is obviously not to scale at all, right? Now I'd rather, I mean, because I've sort of figured out here that k is negative just graphically, by the process of elimination, we know the answer is going to be D or C. And in fact, it's almost certainly going to be C, negative 9 over 4. If k is equal to negative 1, then one parabola starts there like that, and the other one is here, opening that way. So, I kind of know already that the answer is going to be negative 9 over 4, but it would be nice to somehow derive this in a nice way. So what if I take the two equations solve for k in both situations. K is equal to y plus x plus 2 squared, and k is equal to x plus y plus 2 squared, and set these equal to each other. This doesn't look like it's going to be nice and easy to solve, right? This will give us No, so this is saying for a fixed value of k, it's telling us the points of intersection. That's not really going to work. What I could do, so I have y in terms of x. I could do this and see what happens. This also looks like it's going to be pretty messy. Yeah, I don't really want to expand this. We're going to get a 4th degree polynomial in x. And it's not like there's some kind of thing we can do with only even powers of x, right? There's certainly going to be odd powers of x in there. So another thing to recognize, because these two parabolas are reflections of each other in the line y equals x, that's a key. That's a key right there. They have to intersect at a point where x equals y. And the slope of the tangent line, I'll just write this as y prime has to equal 1. The slope of the tangent line has to equal 1. I guess it could also be -1. But again, just graphically, I'm pretty sure the picture we're looking for is something like this. Okay, so maybe we can use this information to do something. So what I'm going to do is I'm going to treat these both as functions and take a derivative and see what happens. And if I take the second equation, x is equal to k minus y plus 2 squared, and if I take a derivative of this, I get 1 is equal to -2 y plus 2 times y prime. So if I now set y prime equal to 1, the first equation gives me 1 is equal to -2 x plus 2. And again, if I take this equation and set y prime equal to 1, I should also get y is equal to -5 over 2. And we knew that x and y have to be equal for this intersection to do what we want it to do. Wait, is that even necessarily true? There could be more intersections between these things. These two parabolas will intersect along this line, but they will have other intersections not on that line. Like we'll have an intersection somewhere over here. But if they intersect tangentially, then I think this pretty much has to be true. Okay, so if x and y are both equal to negative 5 over 2, let's take one of these equations. Y is equal to k minus x plus 2 squared. So negative 5 over 2 is equal to k minus negative 1 over 2 squared. Yeah, so this is turning out to be the answer that I had deduced earlier. So we knew already the answer was negative 9 over 4 just by ruling out the options, but I typically like to do these multiple choice style questions by still deriving the answer where I think it's feasible or appropriate. In writing an exam, this looks like an exam question. If this were an exam question, in writing it for real, I would have no problem just completely using process of elimination. But it's just nice to see sometimes that the answer can be derived like this. So that's a nice little problem. It's interesting to me that I didn't immediately see how to get there directly, but these two pieces of information were, in fact, we didn't actually use that one necessarily. But knowing that, if you picture these parabolas and the way they look, for them to intersect tangentially, you would need, at the intersection point, the slope of the tangents has to be equal to 1. So using that allowed us to get there pretty easily. Thanks for the submission, and thanks for watching.